Imagine you're at $100 trillion. The world is crumbling. You have a choice: repair the planet that raised us, or start again on a new one. Mars is a frozen desert with almost no atmosphere, just 0.6% the pressure of Earth's. To begin changing that, we need to unleash vast amounts of greenhouse gases to trap heat. Deep beneath Mars' southern ice cap lies a hidden stockpile of frozen carbon dioxide. Some scientists suggest mining it, or even detonating charges below the surface, just to release a little gas. It sounds dramatic, because it is. With no natural systems to help, reshaping the planet means turning to extreme solutions. Nearly 80% of all human carbon dioxide comes from burning fossil fuels for energy, transport, and industry. That's where most of the damage and most of the opportunity lies. Fixing climate change is possible. We just need to act fast. Clean energy solutions like solar and wind could cut energy emissions by 70%. Shifting to electric vehicles could lower transport emissions by 90%. And with carbon capture and green hydrogen, we could slash industrial emissions by 30%. Together, these solutions could reduce emissions by 25 billion tons annually, bringing us closer to a cleaner, safer world. Dust storms on Mars can last for months, wiping out solar. Nuclear is the only stable solution. It isn't just energy Mars needs. To power a colony, we would need to build an entire energy system from scratch. This includes shipping and installing nuclear reactors, designing and implementing solar panels that won't get buried in dust, and battery systems that store enough to survive freezing Martian nights. To live on Mars, we need to build fully sealed, radiation-proof habitats, systems that recycle every drop of air and water, and grow food in pressurized greenhouses. Back on Earth, we can cut emissions simply by retrofitting our buildings, better insulation, smarter energy systems, and greener heating. Sending just 1,000 people to Mars will still take over 20 heavy launch missions, each costing around $450 million. Factor in cargo for habitats, food, and fuel, and you're looking at over $30 billion in transport costs alone. Agriculture is responsible for about 24% of global greenhouse gas emissions, mostly from livestock, fertilizers, and land use. But we can reduce this dramatically by investing in precision farming, regenerative practices, and alternative proteins like plant-based or lab-grown meat. These solutions could cost around $400 billion globally, less than 0.5% of global GDP, and feed billions more efficiently without harming the planet. On Mars, humans would have to contend with extreme environment challenges. One of the most significant is microgravity. Prolonged exposure to low gravity causes muscle and bones to weaken, leading to conditions like muscle atrophy and bone density loss, potentially making even simple tasks a struggle. Astronauts on the International Space Station already experienced these issues after only a few months. On Mars, the lower gravity and radiation exposure from the thin atmosphere can result in long-term health problems, from weakened immune systems to increased cancer risk. This means constant medical monitoring, protective habitats, and healthcare infrastructure would be necessary, all adding to the immense cost. When you look at the costs and challenges, Mars colonization seems almost impossible. Trillions in infrastructure, health risks, and no guarantee of success. On the other hand, we already have the tools to tackle climate change and protect human health on Earth. By investing in clean energy and sustainable solutions, we can solve this problem today, not centuries from now. The question is, do we build a house in space or fix the one already on fire?